If you follow along with me, I can assure you that you will be having a solid understanding of aerodynamics, the basics of engineering, and rocket science. Previously, we have seen the generation of light. We need to understand how a diode and an LED works to explain how OLED works. From the previous video, remember that electrons are found around the nucleus in orbitals at different energy levels. And these atoms are stable when the outer orbitals are half-filled or completely filled. The electrons fill from a lower energy atomic orbital to a higher energy atomic orbital. The coefficient of orbitals S, P, D and F denotes the energy level, and the superscript denotes the number of electrons. And the order in which these electrons fill in an atom is given by the great scientist Niels Bohr, and he named these electrons filling from higher to lower energy atomic orbital as Aufbau principle, and it goes like this: 1s to 2s to 2p6, 3s to 3p6, 4s to 3d10, etc. Without using this principle, we can easily tell the valence electron, that is the electrons at the outermost energy level. Let us take the semiconductor silicon. Silicon has 14 electrons and the number of valence electron is 4. Hybridization of atomic orbital, it takes place mostly when two atoms join together. The hybridization is shown here because sometimes when atoms form a molecule, the structure of orbitals will change, and the silicon structure inside a diode may look like this. The boron has a total of 5 electrons. Of that, 3 are valence electrons. When boron is mixed with silicon, it forms a structure as shown. And notice, at first sight, the missing of electrons in the lattice may mislead us to think the material is positively charged, but it is actually neutral. And since one electron in the silicon lattice is missing, it is called p-type semiconductor. Similarly, arsenic has 5 valence electrons and form a structure like this, leaving 1 electron free in the lattice. This is called an n-type semiconductor. The introduction of impurities, in our case boron and arsenic, into a semiconductor crystal is called doping. Of course, the conductivity of the semiconductor changes due to doping. Now let us join the n-type and p-type semiconductor and the junction where both these types meet makes a new neutral type called depletion region. The depletion region is formed by the movement of arsenic's valence electron to the boron side, making the junction neutral, not leaving any electrons or holes to conduct the electricity. And inside the p-n junction diode, it will look like this. In the next video, we will see what will happen when electricity is passed through a diode. This is Gianni, shining off in aerodynamics and medicine. See you in the next video. Stay tuned.